Imagine witnessing the birth of our universe. While we can't turn back time, scientists at the Brookhaven Science Laboratory in New York got us pretty close in 2005. They successfully created a scorching hot substance called quark-gluon plasma, replicating conditions that existed right after the Big Bang. This extreme state is made up of tiny building blocks, quarks and gluons, all swirling together at a mind-boggling temperature of about 4 billion degrees Celsius or a sizzling 39 billion degrees Fahrenheit. Let's dive into a cosmic clash of temps. We're about to see what happens when our super-hot quark-gluon plasma, 250 times hotter than the sun's core, meets the chilliest of space invaders, liquid nitrogen. Imagine pouring just 1 gallon of this icy coolant onto our blazing sun. What would be the dramatic outcome? The contrast is staggering. While our sun shines at a relatively mild 5,500 degrees Celsius, the liquid nitrogen is a bone-chilling minus 196 degrees Celsius. Get ready to explore the explosive encounter between these temperature titans. Time to ignite the universe's most epic temperature showdown. Buckle up and grab those virtual shades. We're about to witness the spectacle of a lifetime. But before we unleash this fiery fusion, let's set the scene straight. Our superheated plasma and liquid nitrogen are not just battling elements. They represent the raw power of the cosmos. Now, here comes the moment of truth. Let's pour that icy coolant onto the scorching sun and find out what astronomical aftermath awaits. Burning anticipation met with a chill and a big reality check. As we gaze up at our celestial giant, it's hard to ignore its blistering heat. 5,505 degrees Celsius, a scorching blast furnace that makes our nitrogen coolant look eerily out of place. So, let's face the facts. No matter how many gallons we pour, liquid nitrogen won't even get close to the sun's surface. It'll evaporate into space long before reaching those sweltering temperatures. The reaction we're waiting for. Sadly, it's not happening on this cosmic scale. Mind blown, or should I say mind frozen. The sun's fiery heat is a staggering 9,940 degrees Fahrenheit. No wonder our liquid nitrogen is in for a rude awakening if it dared to venture closer. But hold up, as it expands into space, turns into gas and vanishes, we catch the real show. A dramatic transformation that brings us exactly what we're here for, pure science spectacle. Whoa, hold on. Let's take a step back and think this through. We're trying to make liquid nitrogen reach the sun, but it instantly boils away at those extreme temperatures. So how can we slow things down? One wild idea is to somehow send the nitrogen straight into the heart of the sun, the scorching solar core. This way, by the time it gets hot enough to turn gaseous, we'll have already witnessed its incredible interaction with our star, and that's a showstopper. Alright, let's imagine we've managed to get that liquid nitrogen into the sun's core. Now it has a long journey ahead, passing through not 1, not 2, but 3 layers of scorching hot atmosphere: the photosphere, the chromosphere, and the outermost solar corona. Each of these zones is like a different world, with its own extreme conditions. As our nitrogen gas makes this perilous ascent, we might just get to see it interact with the sun in some mind-blowing ways. But are you ready for the risks that come with this experiment? Now, here's where things take a dramatic turn. Because if we were to somehow get nitrogen into the sun's core, experts warn it could have catastrophic consequences. The entire solar system, including our home planet Earth, might be at risk of destruction. You'd think this is quite ironic given that nitrogen is often used as a fire extinguisher in confined spaces like mines. But remember, when we talk about the sun's power, even seemingly harmless substances can take on a life of their own and spark an explosive reaction. Now let's get into why nitrogen has earned its reputation as a silent firefighter. It doesn't feed fires like oxygen does, and actually works better than water at smothering them, keeping everything in the fire zone intact. So it's no surprise that nitrogen is nicknamed Captain Extinguisher, or just the Fire Captain, for its precise and powerful role in saving the day, not taking lives. You might have heard that scientists like French chemist Antoine Lavoisier called nitrogen azote, which literally means lifeless. But here's the thing. Don't let its unassuming name fool you, because this so-called lifeless element plays a crucial role in our planet and even in our star. In fact, it's so powerful that using too much of it could upstage the whole show. So, we'll keep our nitrogen experiments cool, with just the right amount to make them truly fascinating. Now, let's bring out the big guns, or should I say, the massive catalyst. To truly showcase nitrogen's potential, we'll give it a mass that's nothing short of astronomical. Imagine combining the weight of all planets in our solar system, or even piling on the equivalent of several Jupiters. Yes, this gas giant is a whopping 318 times heavier than Earth. Don't sweat the cost. We've got a nitrogen goldmine right here on Earth. It makes up 78% of our breathable air after all. If that's not enough, we can just import some from Uranus or Neptune. No need to break the bank. But hold up, let's not get ahead of ourselves. What would happen if this massive nitrogen load were to enter the fiery core of the sun? The experts are painting a dire picture. They warn that such an experiment could be humanity's final showstopper. So buckle up and stay tuned. Let's dive deeper. We're talking about a sizzling solar core temperature of 15 million Kelvin. When nitrogen meets this scorching heat, it doesn't just evaporate, nope, it explodes into gas, expanding at least 700 times its size. The pressure inside the sun would be absolutely crushing, and if things got even crazier, the star might shatter into thousands of pieces. But here's the catch: scientists believe gravity's mighty pull would keep the sun intact, saving us from a catastrophic celestial implosion. Now, let's see how our story takes a dramatic turn. The sun is mainly made up of about 80% hydrogen, and when you mix that with nitrogen, watch out. It creates a highly volatile compound, ammonia. This toxic combination triggers an escalation in thermonuclear reactions within the sun, causing temperatures to skyrocket even more. As nitrogen transforms into gas in the sun's core, it unleashes a tremendous amount of energy. Think of it like a cosmic firework. This release is eerily similar to what happens when meteors burn up while entering our atmosphere. However, don't expect an instant display. Light takes approximately 8 minutes to travel from the sun to Earth. That's 480 seconds of anticipation before we can witness the intensifying radiation and heat reaching our planet. Buckle up, because our day-to-day activities, including taking a casual stroll outside, will become challenging as the air temperature spikes to a scorching 50 degrees Celsius or 122 degrees Fahrenheit. Even if you stay indoors, the sun's radiation can still cause skin damage and temporary vision impairment. On top of that, get ready for catastrophic weather patterns: melting glaciers, killer hurricanes with snowfall that can easily destroy lightweight structures and uproot trees, followed by a shift to warm showers and thunderstorms. Unfortunately, this apocalyptic scenario will render tropical vegetation uninhabitable, putting millions at risk of starvation in its devastating aftermath. The heat's not done yet. In fact, it's just getting started. As temperatures skyrocket, water evaporation rates will also take a massive leap forward. Sounds like bad news. Yes, because the only thing standing between you and this fiery onslaught is clouds. They'll roll in to block that harsh sunlight and bring us some much-needed relief. But hold on to your hats. That temporary reprieve won't last long. The air that's been building up will unleash its steamy fury, making it tough for anyone to catch their breath. And if you've got pre-existing health conditions like lung or heart problems, the consequences could be deadly. You think you're the only ones who'll struggle in this extreme heat. Think again. In these blistering conditions, even the toughest organisms, like single-celled creatures and some marine life, will be put to the ultimate test of survival. And let's not forget about the plants. They'll need to dig deep to stay alive too. But here's a mind-blowing twist: this intense heat isn't just a human problem all. It's actually putting our very own star under stress. The sun is constantly fusing stuff together, which means it's gaining mass and getting stronger by the day. And that's not good news for its lifespan. In fact, it could significantly shorten its life expectancy. Who knew we'd be pushing the limits of science more than a lab experiment with some cleverly stuck on plasma? Here's where our experiment and the cosmic one take a drastic turn. Our sci-fi nitrogen idea just doesn't cut it in reality. First off, let's be honest, any makeshift nitrogen carrier we conjured up wouldn't survive the harsh journey to the sun. Its materials would vaporize in an instant from the extreme heat. Not to mention, no matter what material we used, it'd burn up long before reaching the solar core. And that's just the beginning. Even if we had a magic nitrogen delivery system, getting close enough to the sun is easier said than done. The intense heat and radiation would make it an impossible mission for any spacecraft or object to reach the center of our solar system. But wait, there's even more that makes our fantasy mission a real non-starter. like a massive traffic jam in space. If we somehow manage to get our nitrogen carrier pointing in the right direction to harness the sun's energy, a powerful force called light pressure would actually push it away from the sun. And then there's the staggering distance, 3 times farther than Mars, making it a 5 times more energy-intensive journey. That's like trying to run a marathon, but with a backpack full of bricks. We're not quite ready for that kind of intergalactic feat just yet. So, I'm sure you're curious. What other challenges would come our way if we dared to send nitrogen to the sun? You're probably wondering, where did this wild ride even start? Well, let's take it from the beginning. We explored an ambitious, and might I add, completely impossible mission to send liquid nitrogen all the way to our star, the sun. And yes, someone did actually think of this outlandish idea. As crazy as it sounds, this thought experiment can help us better understand just how enormous space is and what makes certain missions practically impossible for now. So buckle up, because we're about to dive into some mind-blowing facts that made our sun-bound journey go from interesting to utterly unrealistic. Get ready for some real-life examples of zany ideas turning into genius solutions. Just like those trailblazers who thought, why not? A crazy concept actually came to life in Los Angeles. A group dared to imagine a sea of plastic balls floating on their city's reservoir. And you won't believe the amazing outcome that followed. These bouncy balls didn't just stop at being an unusual sight. They also provided shade to the water, preventing it from overheating. The result: a cleaner reservoir due to the temperature drop. Who knew a seemingly bizarre idea could bring such practical benefits? And here's the cherry on top. The wild experiment didn't just stop at being talked about, it actually earned some serious appreciation from the local community. The project was more than just a curiosity, but also a solution that improved their surroundings. So, take this as an inspiration to think outside the box and never be afraid to question the ordinary. After all, who knows where your next brilliant idea might come from? Stay tuned for what's coming up next. We've got some fantastic content lined up for you. Don't forget to hit that subscribe button and share the fun with your friends.